Good evening, everyone. Welcome back to another session on retail analytics. In today's session, we will be discussing on CRISP MLQ methodology. Okay, CRISP MLQ, that is cross-industry standard process for machine learning with quality assurance. Okay, this is one of the widely used project management methodology for data mining. Okay. In this session, we will be discussing on the stages of analytics. Okay. And then we'll also be talking about the CRISP MLQ methodology. Right. In stages of analytics, we will discuss on descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. So these are 4 stages. Okay, to be precise, few also say that these are 3 stages of analytics. Okay, again depending upon the requirement. So how a model, how a business is looked at. Okay, first we'll understand the descriptive analytics part. Okay, so here we are talking about what has happened. Okay, we are saying what happened, right? And then diagnostic analytics, we are dealing with why something happened. Okay, this is at a high level, guys. Right? And then in predictive analytics, so what are we dealing here is what is likely to happen. Right? And after we dealing with what is likely to happen, we have something called as prescriptive analytics. Now, prescriptive analytics is what needs to be done ultimately. Right? This is talking about the solution. If you do this, your business problem is addressed, or you are supposed to be doing better comparatively. Right? Again, it depends on what is that you're dealing with. Okay. So when you say stages of analytics, it depends upon what is being or what is the ask. Based on past business, that is, you are looking at past data and you are trying to summarize all of these, right? You're using historical data, that is why something has happened, right? And then you're also talking about what's or what is something likely to happen. All of these things needs to be analyzed. Let's say you have a store, a retail store. How do retail stores make money, or how do they make profits? The products, right? But they sell the goods, that is the, be it a grocery or FMC, yes, basically FMCG, right? Let me put this right. Fast moving commercial. So what happens is, as an analyst, as a data scientist, you will come up with a model that will predict that a certain amount of percentage, that is a certain percent of the customers are not the regular one or returning customers. Okay, one-time visitors. And this prediction will give you the information that the customer is not returning. Let's say, for example, this particular customer buys one product, he likes it or he doesn't like it. Okay. Based on this past data, you have understood that he's purchasing one particular product and is not coming back for any other purchase. It could be a lot of reasons. There could be a lot of reasons why this particular customer is not returning for business. And based on your prediction, based on the data scientist prediction, you come up with a model which will say that, hey, you know what? Sell him, this particular customer, sell him the product low price, multiple products. Okay. So what you do is, you are not losing on your business. You are saying here the products count has increased, right? And also the prices have also increased. Okay, there is no case of loss or effect on the customer return. That is, will he be able to be a potential returning customer, a regular customer, is what we are talking. So here, even though the prices have been decreased. They are decreased based on the product category. Okay. So still the customer is a potential customer to this particular retail store. Correct? So if your business objective, in your business objective, you have certain things like you have, this is about the stages of analytics, right? We also have the crisp MLQ methodology. Okay, as a data scientist, you need to go through these stages when you are coming up with a model, when you're building up a model. This approach is being by far used by the across the community, that is data science community, for data mining. Right? The first stage. Basically, there are 6 stages, 6 phases. First case is, that is first stage is business understanding. Okay, it means first you have to understand the entire business. Okay, all of the operations. And then here you will be able to identify the objective, right? Conditions, that is conditions, constraints, and also remember friends, we should not divert from the object. Okay, so you should be taking up one step at a time. Okay, and these understanding business, these objective and conditional, that is conditions and the condition statements and constraint, should be in optimization terminology. Right? That means it should be short and precise. Short and precise. So once the business understanding and the data understanding is completed. Okay, you need to understand that these are the important stages. Okay, so in data understanding, you have these different data types. Okay, you have different data types. And then you also have different ML models. And you need to understand which model to apply. Okay, here you could have categorical data, discrete data, etc. All of that you need to understand them completely. Okay, and then you have data preparation. Okay, in data preparation, you process the data, you do a exploratory data analysis, EDA. Right, you are pre-processing the data. Here you are cleansing it. Okay, when you say data engineering, it can also be feature engineering. Once that is done, you build a model. Okay, you come up with a model based on the business requirement. Okay, and this business requirement, you should, like I said, you should not get diverged or deviated from the objective. Okay, right, and then you have model building and tuning. So in tuning, model building and tuning, what happens is you're changing the model, you're changing the model's parameters in such a way that it will predict, okay, the it will improve the model's performance. Okay, how can we improve the performance? That is by doing a hyperparameter tuning. Right, so you keep doing this, that is, you keep repeating this hyperparameter tuning until we get the desired results. Okay, you build the model. So what you do is you go back. If you do not understand, the data, if you're not coming up with a right model, you go back one step and then you do the EDA. Right, clean the data, and then again, if you, like I said, if you do not understand the business, as and when you understand the business, only then you'll understand the data. As and when you understand the data, you will be able to understand the business problem and clean the data accordingly. And once you are able to understand the data, understand the business, you'll be able to build the model. Once the model is built, you have to tune your model accordingly. Okay, and next is model evaluation. right? So in model evaluation, you're testing and evaluating, and here you're seeing that if your model is suiting for the potential business problem. Right? Once you have this, once you have evaluated, you deploy the model. Okay? We will talk about deployment. So in deployment, what is that you're doing is, you cannot walk up to your client and say that, hey, you know what, this is your model, use certain libraries, and here you go, work on it, and then it is ready. Okay? That is not the case. It is a big no. So what we do here is, we want this part to be easy. So you don't want to give away your code, right, which you have built. So what you do is, or for that matter, your client might not have that kind of money where you propose the deployment on, okay, the platform, right? It has to be a user friendly. Next is, after these things, these stages are done, next is monitoring and maintenance. So what are you doing in monitoring and maintenance? In monitoring, if there are any changes in the data, you monitor at the user end. Very important. You're not doing it right away. You're looking at from a user perspective, and then you're dealing with this problem. Okay? Again, based on changes in the data, once the model is built, right, you test and evaluate, your model evaluation is done, and then you deploy. Okay? And then you monitor at the users end. Okay, based on the data, new data you have, right, you keep changing, and then you come up with, based on your findings, you come up with a new potential. See, if you have to address all the surrounding potential problems, okay, that a business might face, addressing just one problem, and it is found that, okay, there are multiple problems, that is, the business is able to look at these different problems. That should not be the case, right? So you also need to look at the entire picture. So here we are looking at the actual class. Okay. So this is your actual class. This is true positive, false positive, false negative, true negative. All right. So how do you measure this? You're saying accuracy is equal to true positive plus true negative divided by true positive plus false negative plus false positive plus true negative. This is how you calculate the accuracy. And when it comes to error, that is false positive plus false negative divided by true positive false negative, that is true positive plus false negative plus false positive plus true negative. This will give you the accuracy. Okay, this will give you precision. I'm sorry. Right? So precision is how accurate are your positive results. So if you were to calculate the precision, you look at true positive divided by true positive plus false positive. All right. We are looking at precision, like I said. We are looking at how accurate our positive results are. If you say positive, how accurate is it? Is it able to identify the patients or any of the attributes accurately or not? Okay, you simply say true positive divided by true positive plus false positive. That will give you precision. Okay. We'll look at sensitivity. So sensitivity is talking about how accurate is your model while predicting your results. Okay, here we are not talking about the positive results. Here we are talking about the predicting the results. So we calculate by true positive divided by true positive plus false negative. Right? We'll also talk about specificity. So specificity is dealing with how accurate the positive results have predicted. Okay, so that is calculated by true negative divided by true negative plus false positive. Okay, and then you have type 1 error. You can also call it as alpha. So type 1 error, that is false positive rate, is equal to 1 minus specificity. Right? You also have false negative. We have looked at false positive, right? And if you were to look at false negative, you say 1 minus sensitivity. And for you to get the F1 score, F1 score, you have to calculate, that is 2 F1, let me put this way, 2 into 2 times of precision into recall, that is precision multiplied by recall divided by precision plus recall. Okay, this is how you deal with F1 or type 2 error. Okay, we have looked at type 1 error and type 2 error. The question is how large your model is. Okay. So you keep doing this. So you can 70% test, that is 70% train, 30% test. And when you're dealing with the overfitting and underfitting problems, so what is happening is, so you train with a huge data, right? So when you train with huge data, this data is getting, or this particular model is having a lot of data, right? It will start to look at the outliers, right? Which will again have the inaccurate data points in our train data. Okay, right? This again will hamper the accuracy if there are a lot of outliers. This is about overfitting. Variance. Whereas your underfitting model, what happens is it will hamper the accuracy of the machine learning model, right? So it is not considering all the data that is required. So it is not looking at a data, it has to be looked at. Okay. That is a difference at a high level, friends. Okay, we have looked at stages of analytics, the CRISP MLQ methodology, right? And we also talked about the error function. Right? And then we also looked at the confusion matrix when your output variable is categorical. And also we looked at when the output variable y is, that is, y is equal to continuous as well. Right? The error function. All right, friends, we will stop our discussion here for the day, and we will continue in our next session. Thank you all for joining. You all have a good day.